Hi there, it's Angus from IGS Electronics and we are back for another video, and today I thought I will quickly run through for my home single to three phase setup, sort of what I would consider a minimum requirements that you should have when you install a single to three phase system in your home, which obviously consists of obviously the inverter drive and couple of other few components that we see here in front of us, and I will run you through all of them, how they are wired in and why I am using them the way I am using them, and then what each component, what role each component plays in this circuitry. So let me reposition my camera and I'll start with the power supply and I'll see you in a bit. So the first thing on my circuitry we're going to looking at is my Allen Bradley 24 volt DC supply and MCBs. Both MCBs are protecting two different things. One of them is protecting my drive, well, protecting cable to the drive, and in some ways the drive itself. And the other one is same thing, comes to DC power supply. Why DC power supply in this circuitry? Is because that's my control power that I use for my buttons and contactors, and I consider that to be most friendly voltage to use for controls, especially when it comes down to buttons and things like that, because if you are unfortunate to touch the cables that has 24 volt DC going through it, you ain't gonna feel a pinch. Not telling you should be doing that, but you're not gonna feel anything. So I would class that as a very safe control voltage, and it is used very widely in control industry, and in my case I am doing the same. So I have 220 volts going in, and it gets converted to 24 volt DC direct current. That doesn't mean there's no other ways of controlling the control circuits, and it's just like nowadays the most common voltage that is used in control circuits are 24 volt DC. When you go down a little bit back in the older days, the AC was quite common as well, AC 24 AC, and to 110 volt as well. But these are more or less becoming less and less in the new units. So if you see one of those in any of the control panels, this is the one that runs the most controls. And if you ever have any faults, this is the first one you want to test to make sure you are getting 24 volt DC coming out. So pretty much this is all I would like to say about this 24 DC supply. Let's get to the quickly run through the cabling. So I have a source, which is the power source, coming into the one of the MCBs gets looped, and both of them distribute. One goes into inputs down here, which as you can see is 220 volts, 220 to 240 volts going in, and 24 DC 2.5 amps coming out, and they are pretty much going off to all the equipment that we are going to be controlling in the system. So let me reposition camera and we'll have a look at the first control part of it. Next part on this system is a contactor, and you say, why do you need contactor if you have the drive? So basically the reason I am using contactor, and I would very strongly advise anybody who's installing a single to three phase system at home are using a contactor, is to have a means of using e-stop. If you look down the bottom, I got the e-stop that removes the power from the motor, period. As soon as the system sets off, once you want the system to stop, and then only one really safe way of doing that is removing the power from the motor itself, not the drive, the motor. So if you see down there, I have just get a bit closer. I have power going in, and you can see my three phases in the bottom are coming out, and then they're going into the contactor in here. You can zoom in a little bit, and come down there, and then they go through the contactor and then come back out, and then they go to the bottom of the little control board. The control units will go down there, they go to the motor down there. So this way, if in event of default, or if the emergency, something happens, I have a means of smashing that e-stop button, and you can have multiple of them into the system, as long as they are all in series. So you can stop the whole thing in one go, and you should really use e-stops at all points of where you stand, and it could cause harm to you, whatever is spinning. So that would be the reason you would need those e-stops to be all over the place, where you would be sort of needing to, if it's an event emergency, to quickly click the e-stop, and that will depower this contactor and will remove the power from the motor on the bottom. Just quickly show you how that works. So at the moment, if you can see the little I/O unit, you can see down there, it shows it's on. So we click that one, as you can see, it went off, and by clicking reset, I would call the reset, and you will see in a lot of the systems, if you ever get to see it in a lot of the systems in a control board, reset does power in huge contactors to basically make the system live. But again, it's all different circumstances for different needs. So in my case, my e-stop removes the power from the motor, and if I click reset, the contactor goes in and lets the power go through to the motor from the drive. And then the next part in the system, I have the drive, which is in this case, I have done a couple other videos on the drives, and this drive will be showcased in my next video, which is Allen Bradley PowerFlex 4. Very good drive. It comes with very good functionalities and things like that. So this the next part in the system is the drive. Then I have my little zoom out. My sort of a control station. So with the buttons and things like that. So and then the final piece, if I move to down here, we should be able to get to it, is relay. Why do you use relay? Well, relay gives me better control of how I control the drive. As I will demonstrate later on how that Allen Bradley Live works, you can have also different ways of controlling it. But in the industry, when the panels are built, usually the drives are controlled by some sort of external signal that is latched, rather than using the internal drive control systems that the drive provides in panels and things like that. They're controlled by different things like PLC or relays or whatever else you could use to do it. So in my system, I have relay that has control in the drive, so controls the drive, and it goes off this way, because when I click a little e-stop down here, it gives me even control of start signals being removed as well, which I'm going to run through in a minute, the wiring. So let me reposition and I'll talk you through how everything is wired. So the wiring. So basically, when you build panel like this, which plus if you have a panel like this, is scalable. So if you want a bigger drive and you're using this little relay system like I use down here, and you don't want to mess around to change too much controls into drives and things like that, this is scalable. You can just replace the drive and put all the cables back in, and the system it will work. When it comes down to safety and things like that. So this kind of panel, obviously, as you can see, is quite big for what it is, because I'm planning to add a lot more things to it as I progress in videos. But for now, it looks quite empty. So first things you would normally do is run your power cables. So I have my single phase coming in the bottom, going through my then you send the cables to your MCBs, looped MCBs in the bottom, then they come out and they spur them off to wherever you want to protect. In my case, which is the power supply, and in there it's the drive. From the drive, as you run the cables to the drive, your three-phase comes out, goes through the contactor, comes out of the contactor, and goes into the control units down the bottom, where they all shoot off to this little motor down there. So next part is the controls. The controls here consists of two latched circuits. And if you don't know what latch circuits are, I have made a video before how the latch circuits work, and pretty much I made a video for latch circuit for contactor, but when it comes down to relay down here, it literally is the same thing. When it comes down to normally open, normally closed contacts, once you master the one latch circuit, every other latch circuit you will understand and why things work the way they work. The key in all this system is to understand the basic latching circuit. So and understanding those contacts, why they do what they do, and the power flows and things like that. Once you master just that basic step, you're well in your way of becoming a good control panel builder, because you will know what each thing does. But to get quickly to the controls, I have two separate systems in here. I have like this system in here, which is the emergency stop and the reset, which controls this part. And if you really look at the system itself, it is one single latch circuit. So when I let's say click e-stop onto it, and basically in the previous video, when you look at the start-stop system, this is the same thing. It's just in my case, I'm using the buttons a bit different. So in my case, this red button, which would normally be stop button, I'm using that as my e-stop, and this orange button, which normally would be a green button, which would be like a start button, I'm using as my reset. So if I would say like this would be my start button, it's the same again. It's the same latched circuit. So that system controls just that contactor. When I click that, it basically latches that small contactor into it. And that is it. And then you can see down here, I have another contact block on in front of this little contact down there. So basically, that gives me more things that I can add to a system that I want to be switched on once I reset the system. And one of them is, as you can see down there, I have a number 100 coming in here, which is in my case, which is a minus from the 24 volt DC, which removes as I click the e-stop. It removes, as you can see down here. Let me just quickly zoom in. Here we go. As you can see, my 100 comes in here. I have a normally open contact in here. That does not, if the e-stop is pushed, which we reset. When right now the power is able to flow through, not the power, well, the contact here now is closed and is allowing to power, or whatever I'm trying to switch, whatever you would try to switch and things like that, allowing that to send the closed cable to wherever it needs to go. And in my case, if you look at the little relay, in my case, I need to set this. I do like that. In my case, I am switching my minus down here. So in a case of emergency, it will stop the relay as well. Plus, it will not, which I'm going to show in a minute. This is very crucial, because there's a mistake could be made when you're building this system. Just show you in a minute. When the e-stop is pushed, and let's say you do release the e-stop, it's stopping these buttons to work. So let's click that, and now you can see I cannot operate the drive until I click this reset button. So basically, this thing in here, unless this is closed, it will not let these buttons work. So basically, you are switching another additional cable in here. And in here, as you can have another normally open contact down here, which I use for latching. But all these front ones I can use for anything. And later on, I'll be adding systems to it. This normally open, I got one, 2, and one normally closed system down there. I can use for adding other systems that I don't want to be started as my system goes in emergency mode. So that's pretty much, that is how I control the relay. And relay, again, if you look at this part down here, which is a start-stop part down here, again, for this drive, you don't need to do system like that, which I'll show you in the next video, how you can do it easier and simpler. but because I build panels and then I do system the way it's as safe as I can get. So in this part, as I reset the system, so and now you can see down there, I can, when by clicking that start, my small relay, as you can see, is turned into green. That way I latch that relay exactly the same way I latch the contactor, and it closes the signal, closes one of my normally open contacts in the relay, and operates the drive over there, sets the drive to go. And first demonstrate in a minute my e-stop system. So if I start it up, the drive is spinning, but as I click the e-stop, the system stops completely, and as you can see, my drive is still ramping down, but it's got no power. So basically, if you would, obviously you can't send, there is a way for sending the signal to completely shut off the acceleration very quickly and things like that, but these things can fail. So that way, I use e-stop, depower the motor from the power, and I don't really care what's going on in the drive, because he can't do anything unless the system is fully reset. And that, my folks, are sort of my home single to three-phase setup. I hope that is more or less educational for whoever wants to do it. And the button, obviously, button station down there, I've got this button down there I would use. You can use for anything, because I just built this station so I can test all different other drives and pretty much learn all about them. And then obviously I'm not a master of all the drives, but I do like learning about them and then showcasing whoever wants to watch it and how they work and things like that. I've got my potentiometer station down there and things like that. So basically, I hope that makes sense. So this is how I would recommend your system to be set up. Obviously, this can be easily compacted in a nice, beautiful panel, where you can like have a nice little button station like I have in here. You're very cheap, you can get them pretty much everywhere. I am a big fan of Schneider goods, so I use Schneider switches and things like that. Obviously, you don't have to go that expensive. There's a lot more cheaper ways of doing it, but I'm just big fan of Schneider, Siemens, Allen Bradleys, and all things like that. It's the most common that we use in UK. So that will be about it about this system. Hope it makes sense, and if it doesn't, do let me know in comments if you need any assistance of understanding anything I missed. So other than that, thanks for watching, and I will see you in the next video.